An electric bulb of resistance 20 ohms and a resistance wire of 4 ohms are connected in series with a battery of 6 volts. Draw the circuit diagram and calculate the following. So here's I have a circuit diagram. First I have an electric bulb of 20 ohms. So I'll just draw this. This is my electric bulb, which is of 20 ohms. It's connected in series with a wire of 4 ohms. So this is my wire of 4 ohms. They're connected to a 6 volt battery. So I connect to a 6 volt battery. This is 6 volt. First I have to calculate total resistance. Now total resistance is very direct. We have the bulb and this 4 ohms are connected in series. So the bulb and the resistance is connected in series. So because it is connected in series, the bulb is of 20 ohms and the resistance is of 4 ohms. So the total resistance R is 20 plus 4. That is 24 ohms. So total resistance of the circuit 24 ohms. Now we need to find the current of the circuit. To find the current of the circuit, I will draw the diagram again. And so now my diagram now is, I will just make one resistance and my battery here, which is 6 volts. Now this resistance will be the resultant of 20 and 4. So this will be 24 ohms. To find the current in the circuit, the resistance of this circuit is 24 ohms. The potential difference is 6 volts. So the current I we need to find. Use the formula V equal to IR. So V is 6, current we don't know, resistance we see is 24. So 6 over 24 equal to I. So 1 by 4 amperes is the current flowing through the circuit. So the current of the circuit is 1 by 4 amperes. Now we must find the potential difference across both, across the bulb as well as across the resistance. Now let's begin to find the potential difference across the bulb. Here is the bulb. So for the bulb, we know resistance is 20 ohms, which is given to you here, 20 ohms. The current we calculated to this circuit is 1 by 4 amperes. It is the same current that will flow through both. So current 1 by 4 amperes. Now to find the potential difference, we use the formula V equal to IR. V we do not know, we need to find of the bulb. And current is 1 by 4, resistance is 20. So the voltage across the bulb is 5 volts. Now we are done calculating the voltage across the bulb. Now it's time to calculate the voltage across this resistance 4 ohms. Now the current flowing through this is the same as a bulb because they're connected in series, is 1 by 4 amperes. So for 4 ohms, the resistance is 4 ohms, current is 1 by 4 ampere. So to calculate the potential difference, we put V equal to IR. So V equal to I is 1 by 4, resistance 4, voltage is 1 volt. So potential difference of the resistance is 1 volt. We want to bring to your notice here, we found that the voltage here was 5 volts and the voltage across the resistance was 1 volt. And the total voltage, if you see in here, is 6 volt. So 5 plus 1 equal to 6. That's what happens in series. The total voltage V, potential difference V, equal to V1 plus V2. Let's go ahead and try to find the effective resistance in this circuit diagram. Let's examine the circuit diagram. Now look at R1 and R2. You'll definitely agree they are in parallel. So to find the effective resistance, we write 2 ohms, 2 ohms are in parallel. So if they are in parallel, we say 1 by r equal to 1 by 2 plus 1 by 2, 1 by r, 2 by 2 equal to 1. So 1 by r equal to 1, that means r equal to 1. So the effective resistance of this is 1 ohm. Similarly, the effective resistance of this also will be 1 ohm, and effective resistance of this too is 1 ohm. Effective resistance of 8, 7 and 8 is also 1 ohm. If I were to draw this diagram again, it would be, so here I would write 1 ohm. This is the resultant of both 1 ohm, 1 ohm and 1 ohm. Now to find out if it's series or parallel, here look, my current is flowing here, and at this point my current breaks up into two parts. One is going here on this side, and the other one is flowing along this branch. So now this yellow is flowing through 1 ohm, the same is flowing to 1 ohm. So the 1 ohm and 1 ohm are in series. So the total resistance will be R will be 1 plus 1, that is 2 ohms. So here I am going to put 2 ohms. That is the resultant of these two resistors. On the other side, here I have the blue resistance, the blue line. So here the current comes, it flows through 1 ohm, then it goes here again, it flows to the other 1 ohm and it goes back. So here too the resistance 1 ohm and 1 ohm are in series, so resistance total will be 2 ohms. So the total resistance, the effective resistance here, I'm going to write it as 2 ohms. This is my point A and this is my point B. Now if you look up here, 2 and 3 are connected in parallel. 2 ohms, 2 and 2 ohms connected in parallel. So total resistance will be 1 by R equal to 1 by 2 plus 1 by 2, and that is 2 by 2, that is 1 ohm. So the effective resistance of this entire circuit is 1 ohm. So you do this calculation in 3 steps. 5 resistors are connected in a circuit as shown. Find the ammeter reading when the circuit is closed. So first we need to find out the resistance. So let's start off here. Now we'll start off at this point B. So current flows at B. From B the current will split into 2 arms, one flowing through 3 ohms and then again 3 ohms and back again here. So this 3 ohms are connected in series, while the other is flowing through 3 ohms here. So the resultant of 3 ohms and 3 ohms, since it is in series, why is it in series? It's the same current C flowing through both. The same current flowing through both these. So the resultant here will be 3 plus 3, that is 6 ohms. So now this, I've calculated the resistance of this, and it was 6 ohms. And this I know is 3 ohms. Now let's go ahead and calculate this resistance of 6 ohms and 3 ohms. And you know 6 ohms and 3 ohms are connected in parallel. So we have 6 ohms, 3 ohms connected in parallel. If it is connected in parallel, I will do 1 by R equal to 1 by 6 plus 1 by 3. So 1 by R, you have 6 here, 1 plus 2, 1 by R equal to 3 by 6, which is 1 by 2, so R equal to 2 ohms. So here we know is 0.5 ohms, this is 0.5 ohms, and the resultant of this has worked as 2 ohms. So we'll draw the circuit diagram again. So for this circuit diagram now, this becomes 0.5 ohms, 0.5 ohms, and we calculated this already here, this one as 2 ohms. And we look up here, we see that the 0.5 ohms, the 0.5 ohms and the 2 ohms are connected in series. So the total resistance R will be 0.5 plus 0.5 plus 2. So the resistance is 3 ohms. Now we draw the circuit once again. Now we know the resultant of this circuit is 3 ohms. And the current and the voltage in this circuit is 3 volts. So to find the current, we do Ohm's law. V equal to IR. V is 3, I we do not know. The R we calculated here, the resultant is 3. So the current will be 1 ampere. So the current flowing through this circuit is 1 ampere, which means this ammeter reading will be equal to 1 ampere. Here's the circuit diagram given to us. There are 3 resistors connected in series. The current and the voltage is given to us. We need to find the value of R. So for this, since the potential difference is 12 volts, the current is half ampere. So we put V equal to IR and we'll find the total resistance of this circuit. So 12 half into R, and we see the resistance is now 24 ohms. Now the resistance of this circuit is equal to 5 ohms plus 10 ohms plus R, because they're all connected in series. So R equal to R1 plus R2 plus R3. Now we know the R is 24 because we calculated here 24. R1 is 5, R2 is 10, and the R3, that is R, we need to find. So 24 equal to 15 plus R, and R equal to 24 minus 15, which is 9 ohms is R. So here is 9 ohms. For the circuit diagram shown in the figure, find the value of the current through 6 ohms and potential difference across 12 volt resistor. So let us take up first 6 ohms. Now see here we have 6 ohms and 3 ohms, and these are connected in series. So which means the total resistance will be 6 ohms, 3 ohms in series. So total resistance will be 6 plus 3, that is 9 ohms. So here the resultant of 6 and 3 is 9 ohms. This is 4 volts. To find the potential difference across 9 ohms, we have to find the potential difference across these 2 points, that is A and B. So you know the potential difference across A and B is equal to the same as that of the battery, because it is connected to the battery. So that would be 4 volts. So for 9 ohms, let's see the current passing through 9 ohms. We know the potential difference is 4 volts. The resistance is 9 ohms. We do V equal to IR, and V here is 4. The I we do not know. The resistance is 9. So I is 4 by 9 amperes. So current flowing through this circuit here to this arm is 4 by 9 amperes, which means the current flowing here is also 4 by 9 amperes. The same current is flowing through both these. So the current through 6 ohms equal to 4 by 9 amperes. Now let's go ahead and find the current in this arm. So in this arm we have 2 resistances. One is 12 and 3 connected in series. So 12, 3 ohms in series. So total current R is 12 plus 3, and this is 15. So this total resistance here we will put as now 15 ohms. To find the current in 15 ohms, we need to find what is the potential difference across these 2 points. And because it is in parallel, we know that the potential difference will remain the same, that is 4 volts. And the resistance here is 15 ohms. So when we use the formula V equal to IR, we know V is 4, I we do not know, and the R is 15. So the I equal to 4 over 15 amperes. So the current flowing here will be 4 by 15 amperes. So to go back here, the current in this arm is 4 by 15 amperes. And if we want to know the potential difference across 12 ohms, all we need to do, resistance is 12 ohms, the current to 12 ohms is 4 by 15 amperes, and we'll do V equal to IR. I is 4 by 15 and the R is 12, so it will be 48 by 15 volts will be your voltage across 12 ohms, which is equal to 3.2 volts. So this answer will be 3.2 volts. The current through 6 ohms we already found out, and that was 4 by 9 amperes. Let's go ahead and find out the resistance in both these circuits. For the first circuit, I have 6 ohms and 6 ohms connected in series. So 6 plus 6, that is 12 ohms. That will be my total resistance. So if I were to draw my circuit diagram again, here I would have to draw 12, and this would remain as it is, which is 6 ohms. So here I have 6 ohms, and this is now 12 ohms. Now for the next step, we see that 12 ohms and 6 ohms are in parallel. So if they're in parallel, we do 1 by R equal to 1 by 6 plus 1 by 12. So 1 by R, LCM is 12, 2 plus 1, 3 by 12, 1 by 4. So 1 by R equal to 1 by 4, R equal to 4 ohms. For the next one, we see that 6 ohms and the 6 ohms are connected in parallel. So 6 ohms in parallel, which means the total resistance 1 by R, 1 by 6 plus 1 by 6, 2 by 6, 1 by 3. So R is 3 ohms. This also is connected in parallel. So just draw it in another. If I had to draw this diagram again, it would be, here I have this, I will put here 3 ohms. Just do that again. So this, I know this resultant of this is 3 ohms. So I will put here 3 ohms. And we have seen the resultant of these two also is 3 ohms. So here I will put 3 ohms. Now both these are connected, the 3 ohms and 3 ohms, 3 ohms, 3 ohms connected in series. So resultant is 3 plus 3, that is 6 ohms. Now we need to calculate effective resistance in these two circuits. Now for this first circuit, have you seen the current breaks up into two arms? You have this blue arm here and this yellow arm on the other side. Now in this blue arm, you have the resistance 1 ohm, and the current flows here, and the same current flows through 2 ohms. So the total resistance will be 1 ohm, 2 ohm connected in series. So the resistance here will be 1 plus 2, that is 3 ohms. And for this second arm, we just have one resistance, 1.5 ohms. So if I were to draw the circuit diagram now, here my blue resistance would be 3 ohms. The resultant here is 3 ohms, and on this side we have the resultant here would be 1.5 ohms. That is 1.5 ohms. Now we see that 3 ohms and 1.5 ohms are connected in parallel. 3 and 1.5 ohms, they are connected in parallel, which means 1 by R equal to 1 by 3 plus 1 over 1.5. 1 by 3 plus 10 over 15. And here we take the LCM is 15. So 5 plus 10. So that would be 15 over 15. So resultant is 1 ohm. So the answer for this is 1 ohm. The resultant is 1 ohm. Now for the next one, we see that it breaks up into 3 parts. One part, second, and the third part into 3 resistances. So these 3 resistances are connected in parallel. Now the first resistance is made up of 3 ohms. The same current flows here, which is 2 ohms. So we can say the R1 is made up of 3 plus 2, that is 5 ohms. Now let's go to the next. We have the second one. The second is made up only of 1 resistance, and that is 1 ohm. So your R2 equal to 1 ohm. And then we have the third is made up of 3 ohms here, and then 2 ohms here. 3 and 2 is the same current flowing to 3 and 2. So the R3 is made up of 3 plus 2, that is 5 ohms. If I were to draw the circuit diagrams again, I know I have 3 resistances connected in parallel. I have the blue one, then this is the blue, then I'll have the green one, and last I have the yellow one. So all these 3 are connected in parallel. Now we know the blue one is already, we saw, is 5. So 5. We have the green, which is 1 ohm, and then we have the yellow again, which is 5 ohms. And all these 3 are connected in the 5 ohms, the 1 ohm, 5 ohms. They are connected in parallel. So the total resistance will be 1 by R equal to 1 by 5 plus 1 by 1 plus 1 by 5. If we take the LCM, here will be 5. So this will be 1 plus 5 plus 1, and that is 7 by 5. That is 1 by R. So I'll just go up here and write. So R will be 5 by 7 ohms. So the resultant of this is 5 by 7 ohms.